Hi everyone! Today we're going to evaluate more integrals by substitution. In the last video, we studied the steps on how to integrate by substitution. You can pause the video and read the steps here. We shall now proceed to the examples. Example 1. Evaluate the integral of sine t over cosine cube of t dt by substitution. For our solution, the step 1 is to select the u. Take note that this cosine cube of t is the same with cosine t and the quantity is cubed. And from here, let us choose the cosine t to be the u. So we have the cosine t here. Then let us take the derivative of this equation. So du equals negative sine t dt. Analyzing our integral here, we have the remaining function to be sine t dt, which is positive. So what we're going to do here is to multiply this equation by negative 1. So we have now the left side to be negative du equals the right side is now positive sine t dt. Step 2, let us substitute the values of step 1 to our integral. So we have this cosine t to be u, and we can see the power 3. And in our numerator, the sine t dt is now replaced by negative du. Step 3, let us evaluate now the integral. First, let us move the negative sign outside the integral. Also, let us show this u cube in the numerator with a negative exponent. So we have now negative integral of u raised to negative 3 du. Now let us use the power rule to evaluate this integral. We have now the negative of u raised to negative 3 plus 1 over negative 3 plus 1. Negative 3 plus 1 is simply negative 2. So we have the negative of u raised to negative 2 all over negative 2. The negative sign of the fraction and the negative sign of the denominator will neutralize each other. So it becomes positive. And then, let us now rationalize the numerator with a negative power. So we have now 1 over 2u squared. And then, we write the plus c. Step 4, let us now return the value of u from step 1. So we have the 1 over 2 cosine square of t plus c. This is now the final answer. Example 2. Use substitution to find the antiderivative of the integral of 3x squared times e raised to 2x cubed dx. For our solution, let us select u. In this problem, we're going to choose u with that of the exponent of the e, the 2x cubed, and we write it here. Then taking the derivative of this equation, we have now du equals 6x squared dx. Observing our remaining function 3x squared dx. But the value here is 6x squared dx. We want to show this right side to be the same with our remaining function in the integrand. So we will divide this by 2. So the left side now of the equation becomes du over 2 equals 3x squared dx. Now step 2, let us substitute the values of step 1 to our integral. So we have now the integral of this e, then raised to the u now, times this 3x squared dx is replaced by du over 2. Then step 3, let us evaluate the integral. First, this denominator 2 is a constant, so let us move it outside the integral. And that is now 1/2 of the integral of eu du. This integral of eu is equal to eu itself. So we have now 1/2 times e raised to u plus the c. Now, step 4, let us return the value of the u. So we have 1/2 times e raised to 2x cubed, then plus c. This is the final answer. Example 3. Use substitution to find the antiderivative of the integral dx over x minus 5. Step 1, let us select u, and this time we're going to select the denominator x minus 5. And then let us take the derivative of this equation. So du equals dx. Step 2, let us now substitute the values of step 1 to our integral. So the integral of this dx now becomes du over the x minus 5 becomes u. Then let us evaluate the integral. So we have the integral of du over u is simply the ln of the absolute value of u, then plus c. For step 4, let us now return the value of u from step 1. So the u is the x minus 5. So we write now ln of the absolute value of the quantity x minus 5, then plus c. This is the final answer. I hope you learned something from this video. See you again next time.